This video promotes chemical safety. One protocol is used to demonstrate the safety principles that apply to working with many of the hazardous chemicals used in the modern biology laboratory. It is intended to supplement the formal instruction provided in each institution and each laboratory. This video is not a substitute for a safety training program. The tools of the modern biology laboratory include an arsenal of chemicals. Knowledge of these substances and respect for the potential hazards will allow the research laboratory worker to practice good science safely.
You know, people who start in the lab have the tendency of being extremely concerned with radioactivity. This is really what they are scared of. Phenol and acids and all that, they are not too concerned about because we know exactly what happens if you pour acid on your hand. But I tend to think that these are actually much more dangerous for the kind of research that we do, where we use low levels of radioactivity most of the time. And that these are the accidents one should really watch for, actually.
Where and how you perform a procedure should be determined by an understanding of the task at hand and the chemicals involved. This morning, Gretchen Hannon is going to prepare a series of DNA samples using phenol-chloroform extraction and ethanol precipitation. Her first step is to equilibrate the phenol. The material safety data sheet is a good source of information about a chemical's hazards. Laboratory workers should be familiar with the relevant ones. The MSDS for phenol tells us it is a powerful corrosive and causes serious burns on contact with skin. Gretchen makes sure the phenol is at room temperature before melting it. She also allows for heat expansion in the bottle. Gretchen knows not to put the warm phenol bottle on a cold surface because the glass could crack and allow the phenol to run out. The MSDS for tris hydrochloride tells us it may cause irritation of the skin and eyes. Here's an opportunity to avoid splashes. Whenever hazardous chemicals are used, a lab coat, gloves, and safety glasses provide valuable protection. Be alert for the possibility of the stir bar cracking the bottle. A secondary container provides cheap insurance. Phenol is one of the more hazardous substances in the modern biology laboratory. Always consider safer substitute protocols as they are developed. To reduce risk of exposure, Gretchen avoids working with a large bottle of equilibrated phenol by preparing several small stock tubes. When you work with a chemical, consider whether you are doing anything such as heating or combining with other substances that will increase its hazardous nature. Adding chloroform, for example, enhances the ability of phenol to penetrate the skin. Chloroform represents numerous health risks, including cancer and organ damage. It may be harmful by inhalation or skin absorption, and its effects are cumulative. Phenol-chloroform extraction in large quantities is best handled in the fume hood because of the inhalation hazard. Gretchen has performed this procedure many times. Otherwise, a dry run would help identify problems she might encounter with the workspace, equipment selection and layout, and with her dexterity. Note how she holds the cap as well as the tube to prevent it from unscrewing. After drawing off the aqueous phase containing the DNA sample, the phenol-chloroform goes into an appropriate waste container. Be aware of the splash hazard. With 2 or 3 phenol-chloroform extractions, the samples are ready for precipitation of the DNA. Sodium acetate may cause skin and eye irritation on contact. Ethanol's principal hazard is its flammability. When using small volumes of phenol-chloroform, it is acceptable to work at the bench. Still, the chemical hazards are real. Snapping of microfuge caps can produce splashing. Gretchen uses her hand to shield herself. And she firmly grasps the cap along with the tube while vortexing. Working with chemicals safely means doing all the things required for doing good science. Know your protocol. Execute procedures meticulously. Know your chemicals. Use smaller quantities of chemicals. Consider safer substitute protocols. Wear safety glasses, gloves, and a lab coat when handling hazardous chemicals. Avoid splash hazards. Use a fume hood when handling stock quantities of volatile hazardous chemicals. Be alert for hazardous situations. Use a healthy dose of common sense. Maintain concentration.
There is clearly a danger that just by habit one will forget and one will become less and less careful. The other thing is that people should not work in the lab when they are exhausted. I mean, I love having people working late at night. That means they are really interested in what they are doing. But on the other hand, you know, one reaches a point where one is just too tired to do an experiment properly. And that is bad for safety. That is also bad for the experiment.